Howdy, everyone. Today, we're going to explore the complex world of AI and dive into decision-making processes that drive AI applications today. And how do we categorize their abilities to help assist in handling agent interactions? The way we kind of have been thinking about agents today is they're these super agents, and they can do everything we want them to do. They can go interact with any system we want them to be able to interact with, and they can do all the things that we want them to be able to do. And quite honestly, this is kind of the Hollywood view of how agents work. They're super agents and they can do all sorts of great stuff, but they tend to go a little bit rogue and they start doing stuff that we don't want them to do. And there's a lot of movies over the last several decades that kind of get into these super agents kind of starting to do things that have extreme prejudice against humans. The way we really should be thinking about agents is more that they're a set of agents that are working together, that are collaborating together, that they have a very specific task that they're trying to accomplish, and they have to do that in conjunction with other agents to complete a bigger process or task. I kind of have a view now that's a little bit more of a physical view, but it kind of explains the idea. Say you were doing something like a road project and you have different agents that are directing or doing work or managing the system or filing reports. All of those have to work together to actually create an agentic system. And this is really how we want to be viewing how agents look and operate and act. So when we think about that, how is it that we want that to really happen? How is it that we want to, what are the implications that we have for interacting with agents as we start trying to figure out how we're going to do this? To talk about that, the first thing that we really want to do is talk about what is it that we want to avoid. The first thing we want to avoid is super agency. And this is really how much freedom does an agent have to go off and do whatever it wants to do? We don't want super agency, which means that it can go do anything it wants. The other thing we want to do is avoid over privilege. And this just really says, when we define what the agency it is, an agent has, what it's allowed to do, then it's like, what is it allowed to, what actions can it actually take? Can it read, can it write, can it delete, can it update? So we really want to avoid both the ability to do too much and have too many privileges. So that's the first thing we want to do is avoid. So what is our desire then? So our desire, as we start thinking about this, is first we want to minimize the actions and the access. And this is really starting to think about what it is when we break down the agents, like we had the drawing before of a set of agents. If we have multiple agents, what are the actions? What's the minimal action we need it to do? And for that action, what's the minimum access we need? And if you really think about these in software engineering terms, this really then is what is called high cohesion, which basically just says, you have a high cohesion between an agent, the one task it does, and the access it needs to do that task. The last thing that we really desire is, again, for us to have a set of agents that collaborate, that they're working with each other. We don't want the single agent that's going off and doing everything for us. We want just a set of agents, and we want them to collaborate together. And we think about it in terms, how do we orchestrate those flows? A lot of talk about that, but point is we want them to collaborate. Now, when we start thinking about how we're going to do this and how we're going to do the things we want to avoid and the things that we want to desire, we have to first start thinking about, what does it mean to represent an agent? What we don't want is all agents basically operate and interact and are the same. When we think about how we have agents, there is no one size that fits all. And especially if we're thinking about breaking them down to, different actions, we really need to think about how we're going to represent those agents. And a really good way to do this is kind of think about, agents on a spectrum. They can do minimal things, they can do a lot of stuff. So if we think about a spectrum of what an agent is allowed to do, they're either going to be risk associated with what they're capable of doing, or we think about their capability. And this relates to what we were talking about. There's low risk. In other words, if something happens with that agent, no damage is done. And then there's high risk, where it's connecting to sensitive systems, and there's a lot of risk associated with it. Capability is low capability. It really doesn't have to reason to think a lot. It does not have to figure out where it's going and what it's interacting with. High capability is there's a high likelihood that it's going to interact with systems, and it has to figure all that out. So we think about this in terms of a spectrum, and we really can break this down a little bit further and kind of look at it really more as a set of quadrants. And the quadrants are low risk to high risk, low capability to high capability. So you can kind of categorize how we want these systems to interact. To give you kind of like an idea of what this really looks like, if we think about this quadrant here, which is high capability, low risk, this is really kind of a system like an internal style guide editor, where it can go read information and rewrite it depending on tone or whatever it is that you want to do. So it's really not dealing with sensitive information, but it has a lot of ability to take action. Whereas down here in low capability, low risk, this could be a very simple RAG model that goes off to an internal wiki and brings information back. Again, really doesn't do a whole lot. Capability-wise, it just goes, it reads, it brings it back, and the information it's operating in, very low-risk information. Now, as we start getting into these other quadrants, into the higher risk stuff, if we think of low capability, high risk, this is something like a finance data extractor, right? It has read-only access to sensitive information, finance information, but it extracts it, brings it back, and summarizes it. So it does one task, but it does it against sensitive information. Likewise, if we talk about the upper right-hand quadrant, this is high risk, high capability. And that could be a system that is perhaps like an accounts payable initiate a payment, right? So it has to figure out what the invoice is, who the client is, what we need to do, what actions we need to take, how much are we going to pay, and it actually initiates a payment. So it's high capability and it's high risk because it's actually dealing with financial systems, making actions, paying systems, and that goes against the ledger. So we kind of think about them in these terms. When we think about, again, if we break this down just a little bit further, this lower quadrant, I'm going to kind of just draw this as a green circle. This is very much like systems that we operate in today. We really kind of know how these systems operate, and so there's not a lot that we need to do. We can just treat them more traditionally. Whereas if we're really talking about this upper right quadrant, this is where the more risk is for our agentic system. And this is really an area where we want to provide a lot more focus. So let's break this down a little bit more. If we're thinking about more of how do we categorize agents, we've broken them down by actions and access. What is it that this really starts looking like? Let's break this down a little bit. So if we're talking about low risk, we're talking about limited damage. If we're talking about systems that are more risky, then we're talking about, there's a lot of potential for damage. So we'll just kind of identify these, right? So we have limited damage and high damage. The other thing that we'll kind of categorize how we kind of write out these categories is these areas, they can reason. Agents in these systems can reason, whereas the agents in these systems, they're really not doing any reasoning. What they're really doing is they're taking predetermined actions. Right? We've already decided what it is that they need to do, and that's the action they're going to take. Whereas these are really more non-deterministic. They're going to, with the reasoning, they're going to decide what it is that they need to interact with and the actions that they need to take, on different systems and tools and resources. So they're non-deterministic. All right. So if we kind of know this, so this kind of starts our separating, right? And how we want to deal with agents. The next thing that we need to really kind of think about then is that then what does that mean? When we're building these more action-specific agents, what does that mean? Well, for For the things that are really more high capability, we want them to be ephemeral. In other words, we don't want them to hang around very long. We want them to come in, do their task, and then go away because it's changing all the time. They're applying a lot of reason. There's non-deterministic. So we want these to go away. Whereas these, we can actually make these much more persistent. They can hang around because they're basically just assigned to do a very specific task, and that's how they're going to operate. Again, when we start talking about high capability, we also want to make these have dynamic access. And what this really is saying to us is, again, because they have more reasoning, they have more agency, they're non-deterministic, they're figuring out what they're going to interact with. Because that path changes every time, we want to assess every path through what they're allowed to do. Are they allowed to connect to a tool? What action can they take? Can they read? Can they write? Can they delete? All that needs to be determined based off of the context of what that agent is trying to accomplish. So we really want to think in terms of that. If we think of down here, the access is really what we always think about with normal access. In other words, it's really more of your traditional non-human identities. So these are API keys, their credentials, their certificates, whatever it is. It's persistent, it's predetermined, and we just can let it connect. But we apply, since it's agentic, we apply more reasoning to that action. All right, so that really starts figuring out our quadrants. I'll go back to this focus area, where we really have these high risk, high capability agentic systems or agents that are operating in our system. And one of the things that we want to consider here is that we want to put a human in the loop before an agent, so it does all the stuff we need. We took the example of this as a payment system, initiating a payment in an accounts payable. Before it actually issues the payment, we may want to actually go out, connect with a human and say, this action is about to happen. Do you approve that? If you approve it, yes, then we continue the thing. So as we get into this upper quadrant, we can do other things that kind of make this happen a little bit better. If we think about high risk down here, this is just, maybe there is just extra business controls that we want to do. And this really is very similar to what we operate, how we operate today. So it really doesn't change anything of the way we do our traditional system. All right. So we've talked about, we do not want super agents that are going off and doing everything. We really want to break that down into a set of agents that have very specific tasks and they work in collaboration with each other. But we don't want to treat all agents the same. We really look at it in this breakdown in a 2x2 matrix based on a capability and risk of what we allow those agents to do and what we want, how we want them to behave. And this is the approach that really think about as you're developing your agentic systems.